Hello, welcome to this presentation. Today's question is about stationary points and curve sketching. The equation of a curve is y is equal to 6x squared minus 12x minus 18. Then part A, Roman 1, find the x-intercepts of the curve. Roman 2, find the y-intercept of the curve. And then part B, Roman 1, determine the stationary points of the curve. Roman 2, for the points in B1 above, determine whether it's a minimum or a maximum point. And then finally, we are going to sketch the curve for part C. So let's begin with part A. Let's find the x-intercepts of the curve. At the x-intercept, y is 0. So with this information, we can come back to this equation here. So that means if y is 0, we can rewrite the equation as 6x squared minus 12x minus 18 is equal to y, and y is 0. At this point, we can simplify this equation further by dividing all through by the common factor, which is 6, and that should give us, for this term, is x squared minus 2x minus 3 is equal to 0. So we've divided all through by 6. We can now solve this quadratic equation. You can apply any of the methods you are comfortable with. I'm going to apply the quadratic formula method. So let's use the quadratic formula, which is given as x is equal to negative b plus or minus the square root of b squared minus 4ac all over twice a. So applying this, we know that a, just a minute, a is equal to the coefficient of x squared, which is 1, b is coefficient of x, which is negative 2, and c here is negative 3. So let's do our substitutions. X is equal to negative b, and b is negative 2. So the negative of negative 2 is positive 2, plus or minus the square root of b squared, that is negative 2 squared. For negative 2 squared, we are going to square the negative and 2 at the same time. So negative squared is positive, 2 squared is 4, so that we have positive 4. And then we are going to have minus 4 times a times c. So we have 4 times a, and a is 1, times c, and c is negative 3. And then we divide that by 2 times a, and a is 1, that is 2 times 1. We're going to have 2 plus or minus the square root of, so this is 4. So this negative and negative multiply to give us positive, so that we have 4 plus, and then we'll have 4 times 1 times 3, that is 12. And then we divide by 2. So we'll have 2 plus or minus, this is the square root of 16. 4 plus 12 is 16, and that is 4. Root 16 is 4. And then on the denominator, we have 2. So the first value of x in this part will be obtained by adding. So we have 2 plus 4, that is 6. 6 divided by 2, that is 3. So x is 3. And then the next one we obtain by now subtracting 2 minus 4, that is negative 2. Negative 2 divided by 2, we have negative 1. So the x-intercepts are x is 3 and x is negative 1. Then for part 2, the y-intercept of the curve. For the y-intercept, always you can just come to the constant term, and that will be the y-intercept. So y-intercept is negative 18. So come and say y is equal to negative 18. Alternatively, you can say that at the y-intercept, x is equal to 0. So if you're given the equation y is equal to 6x squared minus 12x minus 18, then you just substitute x is 0 here, so that we have y is equal to, so this part becomes 0 minus this part 0 minus 18. And that gives us y is equal to negative 18. For part B, determine the stationary points of the curve. So when you're talking about the stationary points are also known as turning points. So at the turning points, the gradient is 0, that is dy dx is 0. Originally we have y is equal to 6x squared minus 12x minus 18. So let's differentiate it. Dy dx is, so differentiating this part here, we have 2 times 6, that is 12x, and then the power is 2 minus 1, which is just 1, and then minus 12x differentiated just becomes 12. So we have 12x minus 12. And because it's for the turning points, we have to equate to 0. And therefore, looking at it from this point, 12x minus 12 is equal to 0. We can determine the value of x. That is 12x is equal to 12 when negative 12 goes to the right hand side. And therefore, x is 1. So if x is 1, what is y? Remember, if we are determining a point, then we have to give the coordinates x, y. So if x is 1, what is y? So we're going to substitute back here. So we already know the value of x. So when x is 1, what is y? So doing our substitutions, we will say, okay, let me do it here very fast. Y is equal to 6 times 1 squared, which is 6, minus 12 times 1 is 12, minus 18. And then that should give us negative 24. So if x is 1 and y is negative 24, the turning point should be the coordinates 1, comma, negative 24. Part 2 of B. For the points in B above, this part here, determine whether it's a minimum or a maximum point. So in order to determine whether it's a maximum or a minimum point, we are going to use this diagram. So let's make a table. So here we have the values of x, and here we have dy dx, so that at the center we have the value of x for the point we are testing. Remember, we are testing point 1, comma, negative 24. Let me write it here. 1, negative 24. So we're going to use the x coordinate to determine whether it's a maximum or a minimum point. So let's have this point here as 1. And then immediately to the left hand side of 1 is 0. To the right hand side we have 2. So we are going to determine dy dx, of which we are not going to struggle much. Dy dx we had already gotten up here. That is 12x minus 12. So we're just going to substitute these values of x here and determine the value. So if x is 0, dy dx becomes, so 12 times 0, that is 0 minus 12 is negative 12. So dy dx is negative 12. And if x is 1, so we have 12 times 1 is 12, 12 minus 12, that is 0. And then if x is 2, we are going to have 12 times 2, 24, 24 minus 12, that is 12. So from this result, we can determine the slope. That is the nature of the curve when it is drawn. So if the gradient is a negative, then the tangent to the curve at that point should always be like that. And if the gradient is 0, that is at the turning point, then we have the tangent to the curve at that. And then if the gradient is positive like we have in this case, then the tangent to the curve at that point should always be like that. That is if the gradient is positive. So at this, we can see the nature of the curve. It's a curve that looks like this. So from the left hand side, it falls like that, and then we have the turning point, and then it rises like that for this part. So this point here is a minimum point for the turning point. So we say 1, negative 24 is a minimum. Finally, let's look at the last part, part C, sketch the curve. In order to sketch the curve, we need the following. We need the x-intercepts. So the x-intercepts were, we determined them earlier on. X is 3 and x is negative 1. So 3 and x is negative 1. We also need the y-intercept. Y is negative 18. And we also need the turning point, and the turning point you already have as 1, negative 24. So these should help us sketch the curve. We are going to draw the y-axis and the x-axis, and then we will have the following. We have the x-intercept, so let's label this first, y-axis. This is x-axis. So we have the x-intercepts. We have point x is negative 1, or negative 1 is this side. We also have x is 3. X is 3, so if we have here 1, 2, can approximate it here as 3. So this point, that is for x is 3. And then we also have the y-intercept, negative 18. We can have it approximately here, negative 18. And then we have the point 1, negative 24. So we can approximately have negative 24 here, so that we have the point 1, negative 24 at somewhere here. This will be the turning point. So for the turning point, we're told it's a minimum. So the nature is like this. So we can have that here. So that is what we expect at that point. So let's begin with the x-intercept. X is negative 1. And then we'll bring the curve to pass through the y-intercept, negative 18. So we'll have that. And then it continues like that. And then at this point, we have the turning point, which is a minimum point, and it continues up to that. So it should be a curve. So finally, we have sketched the curve just as had been required in the question. And with this, we mark the end of the solution to this problem. Thank you for watching. See you in the next one.